Well, hello students, welcome to this class with me, Mr. Alfie. And this is mathematics class. In this video, we're going to learn how to shade a Venn diagram. Let's check this video out. So, how to shade a Venn diagram? Let's start with the simple one. Let's say the rectangle is a universal set and the circle is a set A. Now we're going to shade set A. So we just need to set the region inside of set A. This region inside the set A, we shade this region. And this is how to shade a set A. Now, how about to set the region of A complement? As we know that A complement is the element outside of A. So if the circle is the region of set A, that means the A complement all the region outside of set A. Now we set all the region outside of set A. All the region. So all this region who got shaded, this is the region of A complement. This is how to shade the region outside of A. Now, how about shading a set A while there is a set B in the universal set? The thing that you need to focus is set A. We are going to shading a set A. That means we set all the region inside the circle of set A. All the region. Doesn't care if the region also setting the area of set B. So this is all the area of set A. Shade this area. Now, how to shade the area of A complement while there is B inside the universal set? Again, in order to find the region or the area of set A complement, we don't care about B. Let's focus on the set A. So A complement is the area or the region outside of A. So we shade all the area outside of A. We don't care about the area of set B. We set all the area of outside set A. So this is all the region or the area of A complement. Now, how about to determine the region or the area of A union B? So here there is a set A. So you set the region or the area of set A. That means inside of set A. Set it all. And then there is set B. You need to set all the region inside of set B. All the region. So which region is actually A union B? A union B, the region is all the shaded region. So all the shaded regions, that's what you call A union B. So how about A complement union B? As I have told you before how to determine the area or the region of A complement, we set all the area outside of A. First, we want to find the region or the area of A complement. We set all the area outside of set A. So this is the area of A complement. Now, there's a set B. We set all the area of set B. Now, what is the area of A complement union B? Again, if it is union, so the area or the region is all shaded region. How about the intersection? There's a set B and a set A. So there's a set A, shaded set A again, and then there's set B, shaded set B again. This is shaded for set B. So which region is actually A intersection B? So A intersection B is actually the region that got shaded twice. So in this particular set, this is the region or the area who got shaded twice. So now how to find the area of A intersection B complement? As I said before, for set A, let's focus at set A now. We set all the region or the area inside of set A. This region. And then there's set B, but in this particular question, it is B complement. That means all the area outside of B. We set all the area or the region outside of set B. All of them. Remember, the area of set B is not included. We set them all. So this is the area of B complement. There it is. Now, so since this is intersection, that means the region of the area of A intersection B complement is the region that got shaded twice. Like you see here, only this area got shaded twice. Now let's jump to the example. The example comes from your textbooks. Let epsilon, the universal set, and the elements are 1, 2, 3, 4, 5, 6, 7, 8, and 9. And set A, where the elements are 1, 3, 5, 7, and 9. And there is set B, where the elements are 5, 6, 7, 8, and 9. So, list the element of A intersection B. The first way how to find out the elements of A intersection B complement is to list the element of A and B complement. So, as we know from the question that the elements of set A are 1, 3, 5, 7, and 9. And then we are going to find out the elements of B complement. As I have told you before at the previous video that B complement, the elements belong to the universal set but does not belong to B. So what's the element in the universal set is 1, 2, 3, 4, which not belong to the element of B. So the element of B complement are 1, 2, 3, and 4. Next, since we're talking about intersection, so A intersection B complements the elements of A and also the elements of B, or the common element between A and B complement. So, which one is the common element between A and B complement? As you can see, there's one element of A and one also element of B. And then 3, the element of A, and 3 also the element of B complement. So, the element of A intersection B complement are 1 and 3 because these numbers, the only numbers that belong to A, also belong to B complement. This is the first way how to find the elements of A intersection B complement. And there is another way how to find the element of A intersection B complement, which is by Venn diagram. In order to find the element of A intersection B complement, let's represent set A and also set B into Venn diagram. First step, you draw a rectangle as a universal set and draw the region of set A. Next, before we draw the region of set B, we have to know, is there any common element between A and B? Yes, there is. There's a common element between A and B. The common element between A and B are 5 because 5 belong to A and 5 also belong to B. And then 7, because 7 belong to A and also belong to B. And the last is 9, because 9 belong to A and 9 also belong to B. Since there are common elements between A and B, you draw the region for set B, where some part of the region of set B cross the region of set A. So this cross region where you put the common element, which are 5, 7, and 9. So put 5, 7, and 9 in this region. Next, what number supposed in this region? The number supposed in this region is the element of A except 5, 7, and 6. So the rest element of A is 1 and 3. And then what number supposed in this region, which is the element of B except 5, 7, and 9, which are 6 and 8. And the rest of the element of universal set does not belong to A and does not belong to B. We write it outside A and B, which are 2, 4, and 10. So we put it in the region does not belong to A and also does not belong to B. Now, we are going to list the element of A intersection B complement. How to find the element does belong to those set? So we need to set the area of A. So set all the region or the area of set A, which is all the area or the region inside this circle. We shade it very carefully. And then for B complement, we shade all the area outside of B complement. So we set all the area outside of set B. Do it very carefully. See what I did here? I shade all the region outside the circle of set B. Remember, do it very carefully. Now, since we're talking about intersection, that means the region that got set it twice. That's the region of A intersection B complement. As you can see here, this the region or the area that got set it twice. So the number inside this region is 1 and also 3. So the elements of A intersection B complements are 1 and 3 because these numbers are the only numbers belong to this region. Next example. This example also from your book. So let the universal set M-A-R-K-E-T-S and there is set A, where the elements are S, M, A, R, and T. And there is a set B, where the elements are S, E, A, and T. Now, to find the elements of A complement union B is to draw it into Venn diagram. So, draw the universal set first, and then draw the region of set A. And then before we draw the region of set B, we need to make sure, is there any common element between A and B? Yes, they are. The common elements between A and B are S, because S belongs to A, and S also belongs to B. And then there is A, because A belongs to A, and A also belongs to B. And then there's a T. T belongs to A, and T also belongs to B. So we draw the element of B here. So this region is the region where the common element, which are S, A, and T. So what element we're supposed to put here? The element here is the element of A except S, A, and T. So except S, A, and T, there are two elements left for set A, which are M and R. So the element here is the element of B except S, A, and T. So except S, A, and T, only one element from B, which is E. We put it here. And the element does not belong to A and also does not belong to B, but still belong to universal set, which is K. We put it outside A and B. Let's put it here. Now, we're going to identify the element of A complement union B. So for A complement, we need to shade the region outside of set A, outside of this circle. So we shade it outside of set A, all the region outside set A, which is in this region. Set it, do it nicely. This is all the region of A complement. Next, we're going to set the region of B. We set all the region of set B, which is inside this circle. There it is. Since we're talking about union, that means all the elements of A intersection, A complement union B, are the elements who got shade, all the region who got shade. So as you know, the element who got shade is S, A, T, E, and also K. So the elements of A complement union B are actually K, E, S, A, and T.
I think that's all for the mastery, and thank you so much for watching this video. Don't forget to do your assignment edit model and submit it on time. Keep the spirit up and stay healthy. Bye for now.